A lot of people confuse the scientific revolution with the Enlightenment. While the two overlap in many respects, they are technically not one in the same. The scientific revolution took place earlier than the Enlightenment. While there are no clearly defined dates, the scientific revolution lasted throughout the 16th and 17th centuries and was characterized by the emergence of modern science. The scientific revolution resulted in science becoming a distinct discipline, separate from philosophy or theology. This revolution was characterized by numerous advances in the fields of physics, mathematics, astronomy, and biology. It also helped undermine the influence of the Catholic Church. Galileo, Copernicus, and Isaac Newton were leading figures of the scientific revolution. The Enlightenment, on the other hand, extended beyond the field of science and was a much broader intellectual movement. It lasted from the late 17th to early 19th century and emphasized themes like reason, individualism, and skepticism. In many respects, the Enlightenment was anti-clerical. Deism was a major product of the Enlightenment. Deism is the belief that God allows the universe to operate according to natural law, with no supernatural interference. Tolerance, religious liberty, limited government, and human rights are other key themes associated with the Enlightenment. The scientific revolution helped lead to the Enlightenment. Because the two are so closely related, we will include the major themes of the scientific revolution in this lesson. Many important astronomical advances were made during the scientific revolution. Let's highlight a few of them. The shift from a geocentric view of the universe to a heliocentric view of the universe is one of the most important advances of the scientific revolution. Of course, geocentric means Earth-centered, and heliocentric means Sun-centered. Throughout ancient times and even the Middle Ages, it was widely held that the Earth was at the center of the universe. This long-standing view was based on the work of ancient Greek scholar Ptolemy. By the 16th century, the geocentric view was increasingly coming under attack. Nicholas Copernicus formulated the modern heliocentric view, which he set forth in his 1543 work on the revolutions of the heavenly spheres. Copernicus' view revolutionized the field of astronomy. Interestingly, the heliocentric view was met with resistance by the Catholic Church because this new view was believed to contradict the orthodox doctrines of the day. Galileo Galilei was another important figure of the scientific revolution. In addition to being a staunch supporter of Copernican heliocentrism, Galileo helped pioneer the development of the telescope. Because he did not ascribe to geocentrism, he was condemned by the Catholic Church as a heretic and spent the last years of his life under house arrest. German astronomer Johann Kepler is another key figure. Kepler specialized in planetary motion and is remembered for formulating what is now commonly called Kepler's laws of planetary motion. Isaac Newton is arguably the most important figure of the scientific revolution. In his monumentally important work, Mathematical Principles of Natural Philosophy, Newton formulated the laws of motion and the law of universal gravitation. Newton was a giant of his field, and his discoveries form the basis of modern science today. Many scientists of the 16th and 17th century concerned themselves with what they called mechanical philosophy. Mechanical philosophy dealt with issues of matter and motion, and in many ways was a fancy word for physics. Some scientists in the field even proposed primitive variations of atomic theory. René Descartes was a notable pioneer in mechanical philosophy. A major innovation of the scientific revolution was the improved scientific method. The scientific method, of course, is a technique for testing hypotheses and arriving at fact. Now, primitive forms of deductive scientific reasoning have been around since ancient times. The modern scientific method, however, as we know, is a direct product of the scientific revolution. Men like Francis Bacon and René Descartes were instrumental in developing the modern scientific method. Advances were also made in anatomy, mathematics, and other fields. Andreas Vesalius, often considered the father of human anatomy, published On the Structure of the Human Body in 1543. This was a tremendous improvement from previous anatomy texts and had a major influence on the discipline. Other well-known scientists include William Gilbert, who pioneered work in magnetism and electricity, and the mathematician Blaise Pascal, who invented the mechanical calculator and made significant contributions to the area of mathematical probability. Let's review. The scientific revolution is the name we use to describe important scientific breakthroughs that took place throughout the 16th and 17th century. The scientific revolution is closely associated with the Enlightenment, an intellectual movement lasting from the late 17th to 19th century. Nicholas Copernicus became an early leader of the scientific revolution with his formulation of the modern heliocentric or sun-centered view of the universe. Galileo Galilei was another important figure. He pioneered the development of the telescope and was condemned as a heretic for supporting Copernicus' heliocentric view. Isaac Newton is one of the most important figures of the scientific revolution. He formulated the laws of motion and the law of universal gravitation. The modern scientific method, a technique used to test hypotheses and arrive at fact, emerged during the 16th and 17th century with contributions from men like Francis Bacon and René Descartes.